This is the review for, there's a couple pieces, Chapter 8, Chapter 9, and Chapter 10. We're going to start with slope-intercept form, writing equations in slope-intercept form for information for a line. So when they give you the slope and the y-intercept, that's pretty straightforward. Remember, slope-intercept form is in the format y equals mx plus b. We know that the slope represents the m, the y-intercept represents the b, so this equation now becomes y equals 5/3 x plus 4. Next question, they try to trick you a little bit by telling you that the slope is 0 and the y-intercept is -1. So we plug in 0 for m and -1 for y. That can be simplified. We will not accept that as a final answer. So that gives you y equals -1. So you must simplify in that situation. And then again, they try to trick you and they give you 0 for the y-intercept. So -1 for m plus 0, and your answer is going to be this. Don't give me -1x. I don't want to see. I don't want to see y equals -1x. That would be considered wrong. No. Coefficients, whenever it's 1, we don't see the 1. We either see the negative or we just see the variable. Now this is interesting. Where is my page? That is very strange. I don't know what is going on there. That is weird. All right, that might be a problem moving forward, but we will trudge through. Now we have to write this, the line, the linear equation in slope-intercept form when you're given the slope and the y-intercept. I want to get out of that because I need to be, oh, there we go. All right, now we're okay. So again, we have the equation y equals mx plus b. We're given the slope. Now, we aren't given b, we're given actually a point. So we're given a point, and the point consists of x and y values. So those will go in for the variables x and y in this template. So my y value is 2, my m value is 1/2, my x value is 4, and now I'm going to solve for b. So I have to simplify. I'm going to subtract 1. I get 1 equals b. So now I have the y-intercept, which is 1. I have the slope, which is 1/4. So now I can plug in for y equals mx plus b. Y equals, the m is 1/4. The b is 1. We leave the x and the y open because we want to write it as for all the points. Whenever we plug in for x and y, we're talking about a specific point. In this case, we talked about 4, 2. But I want to know what is the equation for all the points. Number 5, same thing. We're going to start with our open-ended template. We're going to plug in values that we know. We know the x, the y. We know the slope is 1. So y is 3. Slope is 1. X is -1. And we're left with the variable b. We're going to add 1 to both sides. We get 4 equals b. Now I know my slope is 1, so I don't have to write anything in front of the x. Again, I don't want to see, I do not want to see y equals 1x plus 4. No. We just leave it as the coefficient, just leave it as x. We know that the coefficient is 1 in that case. And the last one, in this type, we're given our x and y value again. We're given the slope is 0. So y equals mx plus b. My y value is -5. My m value is 0. My x value is -4. And I'm going to simplify. And I get a y-intercept of -5. I'm going to use my general template. Y equals slope of 0, y-intercept of 5. We can't leave that like that. We have to simplify that. So my answer is y equals -5. Number 7, write the slope-intercept form of the equation. Good. So whenever we write in slope-intercept, we have to find out what the slope and the y-intercept is. Since they gave us 2 points, this is going to be x sub 1, y sub 1. This is going to be x sub 2, y sub 2. My slope equation is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 0 minus my y sub 1, which is 1. My x sub 2 is -2 minus my x sub 1, which is -1. That double negative, very important. That's where most students will make their mistake. 0 minus 1 is -1. -2 plus 1 is -1. -1 divided by -1 is 1. So my slope is going to be 1. Now we have a slope. We have the slope and we have a point. So choose one of these points. You can either choose point 1 or point 2. In this case, I'm going to use point 1 just for simplicity. I use my template. My y value in point 1 is 1. My m is 1. My x is -1. And I'm looking for my b. Just checking, making sure that those values are correct. 1 equals -1 plus b. I'm going to add 1 to both sides. 2 equals b. I now have my y-intercept and I have my slope. So I can write a formula in slope-intercept form for the equation that contains the 2 points, -1, 1 and -2, 0. Good. Let's try this one. Again, let's find the slope first. You have x sub 1, y sub 1, x sub 2, y sub 2. You have 4 minus 4, -3 minus 3. You have 0 over -6, which equals 0. That would be my slope. I'm going to use my template. Y equals mx plus b. I have a slope and a point. Again, I'm going to use the first point just for convenience and consistency purposes. And now I'm going to plug in the values. My y value is 4. My slope is 0. My x value is 3 plus b. 4 equals 0 plus b. 4 equals b. I have my y-intercept. Guess I should have circled that in blue. And we get y equals 0x plus 4. You must simplify that. And the equation for the line is y equals 4. And the last one, third and final one, x sub 1, y sub 1, x sub 2, y sub 2. We have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That gives me -2 over -4, which equals +1/2. A negative divided by a negative is a positive, and we're going to reduce each of those numerator and denominator by 2. So this is my slope. I'm going to pick a point. I'm going to stay consistent. Y equals mx plus b. Y equals 4. Excuse me. M is 1/2. X is 0 plus b. 4 equals 0 plus b. And 4 equals b. So my y-intercept is 4. My slope is 1/2. Y equals 1/2 x plus 4 would be the solution to the equation. Number 10, solve each system by graphing. We like this because both equations are given in slope-intercept form. So of the first equation, my slope is -1/2. My y-intercept is 4. So when I graph that, I'm going to graph the y-intercept first. There's 4. And then I'm going to use my slope, which is -1/2. We can put the negative either in the numerator or the denominator, not both. So in this case, I'm going to put the negative in the numerator. So my point, I'm going to go down 1, right 2, down 1, right 2. I'm going to make a line, connect those dots. Oh, that was pretty good. Not perfect, but pretty good. And I'm going to put arrows on those. And now I'm going to draw my other line. I have a slope of 1/2 and a y-intercept of 2. So when I graph that, let's find a good color. Let's use, oh, that is very interesting. 2, and my slope is 1/2, so I go up 1, right 2, up 1, right 2. I'm going to make a line connecting those. Oh, look at that. That was really good. And I'm going to put arrows on that. I look for the intersecting point. The intersection point is 2, 3. So that would be my solution. 2, 3. If I plug in 2, 3 in the top equation, I should get the left side equaling the right side. And that's how I can test and check just in case. Let's look at problem number 11. Again, my equations are given to me in slope-intercept form. I see the slope, 3/2. I see the y-intercept, 4. I'm going to make a dot at 4. I have my slope, which is up 3, 1, 2, 3, right 2. That's somewhere up here. So since I'm off the grid, I'm going to do the opposite. Instead of up 3, I'm going to go down 3. And instead of right 2, I'm going to go left 2. Down 1, 2, 3, left 2. So that's the easier way. If I go off the grid, because this point is an approximation, because I don't have any grid. So that one I don't really know if that's spot on. I'm going to connect them. And draw arrows. And now I'm going to draw my other point. I have a slope of -5/2 and a y-intercept of -4. So if I make a dot at -4, my slope, instead of going down 5, I'm going to go up 5. 1, 2, 3, 4, 5. And then that puts the negative on the 2. So that means left 2. Up 5. 1, 2, 3, 4, 5. Left 2. Somewhere around there. I draw my line. Let's center it up. That looks pretty good. And arrows. And my intersecting point is going to be -2, 1. So that's where they share a solution. And the third one, which is a good one, I like this one. So we have it in slope-intercept form. 1/2, y-intercept -1. Let's graph that. -1, slope of 1/2, up 1, right 2, up 1, right 2. Connect them. Arrows. And now I love this. This is, remember how we have this. This is a little special, right? So one variable, and the variable is x, so the line crosses the x-axis at -2. So if it crosses the x-axis at -2, there it is. And it's going to be a vertical line. So where is the intersecting point? The intersecting point is going to be right there, which is -2, -2 would be. So we have to be really careful. We have to notice and be aware that when there's only one variable, it's either going to be horizontal or vertical, and whatever variable it has is where it's going to cross that axis. All right, this one's a little bit more challenging because we have x minus 2y equals -8. That's not in slope-intercept form. So let's isolate y. So you're going to move the x first. And remember, when we put it in slope-intercept form, the variable comes first, the variable x. We have to divide everything by -2, and we get y equals +1/2, because negative divided by a negative is a positive, and we get +4. So my slope is 1/2, my y-intercept is 4. Let's graph it. So 4 is my point, my intercept, up 1, right 2. I'm off the grid, so I can go back to my original point and go down 1, left 2. I'm going to make a line. Pretty good. Pretty good. Again, here's my second equation. My second equation is x plus y equals 1. We're going to solve for y, so we can get it in slope-intercept form. My slope is -1. My y-intercept is +1. So when I make my point, let's get Philly orange, that's 1, and my slope is -1/1. So I go down 1, right 1. Down 1, right 1. Connect those dots. That was not a very good line. Let's back that up. I thought I touched the line. So let's do this. That's not bad. Good. And it looks like my intersecting point is -2, 3. -2, 3 would be the coordinate of the solution to the system. There's another one where it is not in slope-intercept form, a little bit more challenging. So I'm going to subtract x first. I get -4y equals -x minus 8. Divide by -4, divide by -4, divide by -4. Y equals +1/4 x plus 2. Slope of 1/4, y-intercept of 2. Let's graph it. Two is the y-intercept. Slope is 1/4, up 1, right 4, or down 1, left 4. It's a little bit off, so let's perfect it a little bit. Good. Let's draw some arrows so we know that those solutions go on forever. Let's look at our other equation. X minus 4y equals 12. We're going to subtract x. -4y equals -x plus 12. We're going to divide by -4, divide by -4, divide by -4. Y equals 1/4 x minus 3. Let's get a color. And -3 is my y-intercept. My slope is up 1, right 4, or down 1, left 4. Let's connect the dots, and well, that was pretty good. We look like we have parallel lines. How would we know if we had parallel lines? Well, parallel lines have the same slope and different y-intercepts. They have the same slope of 1/4, but different intercepts. So I know that these lines are parallel. So what is the solution? The solution, or the answer, is no solution, because we want to know where do the points intersect. they don't intersect. So there is no solution. There is no intersecting point. All right, now we get into the inequalities. Draw a graph for each inequality. What I've always told you is write the inequality with the variable first. Since it's eating the 1, when you write the variable first, the inequality should still be eating the 1. So I know that I'm going to have a closed circle because it's equal to, and I know it's going to be less than, so my arrow is going to go to the left. Again, let's write it with the variable first. This time the inequality is eating the solutions. So when I rewrite it, it should still be eating the solutions. It is an equal. So it is, I'm going to have a closed circle and my solutions are greater than 6. This one's pretty straightforward. I don't have to rewrite it. It is just greater than, so that means it's open circle, and greater than goes to the right on the solution starting at -2. All right, here we have steps involved, so we have to isolate the variable first before we graph the solutions. That's going to give me -13 is greater than x. Let's write with the variable coming first. X is less than -13. We are going to have a closed circle over an open circle, my bad, open circle, it's less than, and we're going to the left. So open circle over -13, going to the left. 19, we're going to add 1 to both sides. You get -2 is less than or equal to n. Rewrite it where n is greater than or equal to -2. I have a closed circle because it's equal to. My solutions are greater than -2. Number 20, I'm going to simplify first. Whenever you have double signs, always simplify the expression before you isolate. Now I'm going to solve for the variable. My variable doesn't come first. I'm going to write it first. It's eating the 14, so make sure it still eats the 14 when you write the variable first. It is a less than, so it's an open circle and going to the left over 14. Oh, this is a good tricky one. This is x over 10 is greater than -9/10. What's happening to the variable? 10 is dividing it, so I have to multiply by, or the inverse of dividing by 10 is multiplying by 10. The 10 is in the numerator, so that will cancel with the 10 in the denominator. And that leaves me with x is greater than -9. I do not flip the inequality sign because I didn't multiply both sides by a negative number. I multiplied both sides by a +10, so that does not affect the inequality. My solution is x is greater than -9. I have an open circle over -9. My solutions are greater than, so I'm going to graph to the right. Here we're going to divide by -5, divide by -5. Since we divided both sides by a negative, we have to change the inequality sign. The inequality goes from greater than to less than. 90 divided by -5, a positive divided by a negative is -18. And then I would rewrite it with the variable first. Open circle over -18. My solutions are greater than, so I'm going to go to the right. Divide both sides by 14. 10 is less than n. N is greater than 10. Open circle, greater than goes to the right. And that's it. Hope to see you during extra help office hours if you have any questions.